Welcome back, students. In this video, we'll solve a few textbook problems. So far, we have covered 8 videos covering the basics, how the current flows, our definition of voltage, amperes, current and voltage, the devices for measuring current and voltage, the zero error in those devices, the electric circuits, what are insulators and conductors, resistance, and how the resistance can be arranged like in series and parallel connection. In this video, as I told you, I'll be discussing a few textbook problems. What I mean is, after every key section, there are a couple of questions which have been asked. I'm not going to solve every question. Whatever is straightforward or whatever you can pick up from the textbook, I'm ignoring it. For example, what does an electric circuit mean? What definition of current, unit of current is amperes? So I don't want to repeat all that. Something which is a little tricky or which involves a calculation, I want to take you through that. So page 172, question 3. Calculate the number of electrons constituting 1 coulomb of charge. So the solution goes this way. 1 electron has a charge of 1.6 into 10 power minus 19. Actually, it is a electron means there is a negative sign involved. But for all practical purposes, we are ignoring the negative symbol. That is not required for this calculation. So we just consider the charge of 1 electron as 1.6 into 10 power minus 19. And the question is asking how much electron is required to bring in 1 coulomb of charge. See, this is very minuscule value. It is like a decimal followed by 19 zeros, and that is the coulomb value. And how many such electrons are required to bring 1 coulomb? So in the first and second part of the video, we discussed a formula. The total charge can be calculated by the number of electrons n into charge per electron. Okay. Now in the question, whatever is given is Q, that is Q is equal to 1 coulomb. So you need to find the value of n, that is the number of electrons. N is equal to capital Q by small q, which is equal to capital Q is equal to 1 coulomb, small q is equal to 1.6 into 10 power minus 19. When you solve this, you get the number of electrons as 6.25 into 10 power 18 electrons. So when you substitute this formula, this is how it looks like. Just for 1 coulomb of charge, you have 6.25 into 10 power 18 electrons, with each electron having this amount of charge, bringing in totally 1 coulomb. Going to the next problem, what is meant by saying that the potential difference between 2 points is 1 volts? This is a quite often repeated problem pattern. Either they ask about 1 volt or they ask about 1 ampere. So the potential difference between 2 points in an electric circuit is said to be 1 volt. If 1 joule of work is done for moving a charge of 1 coulomb from one point to another point. So what I mean by one point to another point is, consider a long wire, say 2-meter wire. So some amount of work is required to move the electron from one end of the wire to another end of the wire. That is called as one point to another point. So the formula goes this way. 1 voltage is equal to 1 joule divided by 1 coulomb is equal to 1 J C to the power of minus 1. So this formula and those kinds of things about voltmeter is all discussed in the last couple of videos. Please refer and then come back here. Now there is something what I talked about, work done. There is a 1 joule of work is done. So what is the work done? See, for example, when you move from the first floor to ground floor, there is some amount of work done. The same way, when 1 coulomb of charge is moved from one end to another one end of the wire, there is also work done. So that is what I am trying to say as work done. Then the next question, on what factors does the resistance of conductor depend? This is exactly what we discussed in our previous video, last video. The formula for resistance is R is equal to rho resistivity into length by A. This apart, it also depends on temperature, which is directly proportional. So your answer will go like, the first the thing is nature of the material. We'll follow the same order. We'll follow the same order. Rho L by A. Okay. Nature of the material of the conductor. That is the resistivity, the property of resistivity. That is rho. Then length of the conductor, rho L. 1 meter, 2 meter, 10 meter, whatever. Then cross-sectional area of the conductor, A. All the three fit into your formula. The other external factor is the temperature of the conductor. So these are the four factors which determine the resistance of a conductor. The same question they can slightly ask, list two factors. So you can list only two factors. Now moving to the next question. Will current flow be more easy through a thick wire or a thin wire of the same material when connected to the same source? Same source means, say you have a 3 voltage battery. So one of them is a thick wire, another one is a thin wire. Both are same material, means copper or silver or whatever. Both are same material, copper. Okay, when connected to the same source, which is a easy flow of current, whether it's a thick wire or a thin wire. So the answer goes with this way. This again depends upon the same equation whatever we discussed in the last video. Resistance is equal to rho L by A. So thick wire or thin wire, it falls on the area of the conductor. A thicker wire has a larger area and a thinner wire has a lesser area. You can see that area is inversely proportional to resistance, which means a thick wire has more area, hence less resistance. It provides less resistance. Whereas a thin wire with a lesser area gives more resistance because the area goes the denominator part, and when you calculate, you can just make a mathematical calculation. Say area is 100 meter centimeter square or whatever, and another lesser area is 10. When you divide it, just consider all other factors as one. This is just for a mathematical representation for your understanding. So rho and L you consider as one, just to simplify the calculation. Just put area is equal to 100 and see what is the resistance. Just put area is equal to 10 and see what is the resistance. Then you'll understand what these two lines mean. Okay. So for the current to flow easily, the resistance must be less. This R should be less. This R is less when the wire is thick. So thick wire is easy for flow of current. Okay. Then page 185, question 1. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 voltage each, a 5 resistor, a 8 resistor and a 12 resistor and a plug key, all connected in series. See, in our lesson on circuit diagram and schematics, we discussed that cell is the least or the lowest component and a couple of cells together bring a battery. So in this case, you have one cell 2 volt each. So 3 cells means you have a battery of 6 volts. So you are all going to connect this with the in series with the all the 3 resistance, plug and the battery of potential 6 volts. So it goes something like this. One cell is having a positive and negative. There are 3 such cells, 6 volts. The current starts from the positive and flows towards the negative. This arrow mark is very important. And you have all the 3 resistances series 5, 8 and 12. And then you have the plug here. So thank you so much for listening. In the next video, we will cover some more exercise problems. Bye till then.